meet you all again. Today we will solve the exercise 1.3. Before that, we'll just give a glance at Theorem 1.3 and Theorem 1.5. Let's see what they're all about. Theorem 1.3 says, if x is a rational number whose decimal form terminates means stops. After the decimal point, the numbers which are going, if they stop while dividing, then x equal to p by q. That means that it's a rational number where q is not equal to 0, where p and q are co-prime, and q can be expressed as 2 power n 5 power m, where n and m are greater than equal to 0. And then theorem 1.5 says, if x equal to p by q, where q is not equal to 0, that is a rational number, and q is not of the form, if the denominator is not in the form 2 power n 5 power m, then x has a decimal form which is not terminating and repeating. It won't terminate. It will go on repeating the same number again and again. It will come. Come, let's get into the exercise, right? State if which are terminating and which are non-terminating repeating decimal form. So I have chosen two sums in the first question, that is first one and the fourth one. Okay, so let's solve 3 by 8, right? So we are much concerned about the denominator. This is a numerator, this is a denominator. So let's factorize 8. What do we get? 2 4s are 8. 2 2s are 4, 2 2s are 1. So how we can write is 3 by 2 cube. So it is in the form of 2 power n. So it is a terminating decimal. Okay, if you can express either in the form of 2 power n or 5 power m, it is a terminating decimal. Right? Let's go to this sum, 2 by 11. What is that? Let's factorize 11. 11 is a prime number, so it cannot have any prime factors. So we conclude by 2 by 11. So here 11 has neither 2 nor 5. So it is a non-terminating. It is a non-terminating repeating decimal. Right? On to the second question. Without dividing, say whether the rational numbers have terminating or non-terminating repeating decimal forms. Again, we do the same thing. We factorize the denominator. 1600. 2. 2 8s are 0 0. Again 2. 2 4s are 0 0. Again 2. 200. Again 200. Again 250. Again 225. Again 5. 25 is not divisible by 2. So 5 5s are 25. So this gives us 5. So here we can express it as 15 by 2 power 1, 2, 3, 4, 5, 6. 2 power 6 into 5 square. So here we express the denominator in terms of 2 power n and 5 power m. So this is a terminating decimal. Right? On to the next sum. That is 129 by 2 square, 5 power 7, 7 power 5. Here already they have factorized and put in the form of powers. So now we need to analyze. Now what should be the denominator? It should be either 2 power n or 5 power m or 2 power n 5 power m. Here what we have, 2 power n is there, 5 power m is there. Along with that another number is there. So it is not possible to have a terminating decimal. Only 2 or only 5, that means if only 2 is there, that means it is 5 in 5 power 0, which is nothing but 1. If only 5 is there, that means 2 power 0, which is nothing but 1. So you can either have only 2, you can either have 5 only 5, or both 2 and 5, not any other number along with it. If you have any other number along with it, it is a non-terminating repeating decimal. Hope it's clear. We will again see the third sum and the sum. On to the third sum now. Write in the decimal form. Right? How do you do without dividing? How we go about it? We know the decimals are completely dependent on tens. Okay. So here we have 23 and here we have 2 into 2 into 2 and 5 into 5. 2 cube is 2 into 2 into 2 and 5 square is 5 into 5. And this 5 needs one more pair, that is 2 into 5, 10, 2 into 5, 10, and this 2 needs one more 5. So that's what we are going to do, into 5 into 5. So what we will get, 5 3s are 15, carry 1, 5 2s are 10, 11. 11 by, now this is 10, 10, 10. So what we will get, 10 into 10 into 10, 1000. So you get 0.115. Now we have 143 by 110. So how do we do this? First see if it can be cancelled by any number. So here we see that it can be cancelled by 11. So 143 by 11 will give you 11 ones are 11, 11 threes are 33, 11 tens are. So this will give you 13 by 10. So 10 is there. So the decimal after one number. So it is 1.3. Right? So this is how we express it, decimals. So note the question. Express in P by Q form and write the prime factors of Q. Right? So now we have to be a little bit careful. Here you have 43.12 where 12 is a recurring decimal. So 43.12 is nothing but bar 12, that is 12, 12, 12, that's going to repeat. Okay, so how we do this in the fraction form is, first we need to see how many numbers are repeated. We see that 2 numbers are repeated, so we multiply it by 100. If 3 numbers are repeated, we multiply it by 1000. If 4 numbers are repeated, we multiply by 10,000. Right? So now we have 2 numbers repeated, so we are multiplying it by 100. 100x will give you 4312, that is 2 numbers, it moves that side. When you multiply it by 100, 2 zeros, 2 numbers moves that side. 0.121212, how many over 12 it goes on? And what is our x? X is nothing but 43.121212. Now we subtract it. What do we get? 100 minus x will give you 99x. And we subtract 2 minus 2, 1 minus 1, 0, 2 minus 2, 0, 1 minus 1, 0, 2 minus 2, 0, 1 minus 1, 0. 2 minus 3 not possible. 12 minus 3, this becomes 0. This becomes 12. 12 minus 3, 9. And 0 not possible. 10. And this 10 minus 4, 6. 2, 4, 2, 6, 9.000. So after point, if there are any number of zeros without any number on the other side, they have no value. So we ignore it. So x equal to 4269 by 99. So this is how we express in the form of P by Q. And now write the prime factors of Q. That is a denominator. We have to write the prime factors. So 99 we need to factorize. How do we factorize? 3. 3 3s are 3 3s are. Again 3 1s are 1s are. So how do we write? 4269 by 3 square into 11. Now tell me, is it a terminating decimal or a non-terminating decimal? Yeah, there is no 2, there is no 5. It is a non-terminating repeating decimal. Right? So this is the answer for this. And then on to the next question, 0.12011200111200. Here you don't find any pattern. There is neither a repetition and it all goes average. So this is a non-terminating but not a repeating decimal. Hence it cannot be expressed in the form of P by Q. So it is not a rational number. Why is it not a rational number? It is not a rational number because it cannot be expressed in the form of P by Q, because for expressing in P by Q you should have a recurring decimal. It should be repeating same number. Here 120 and here again another number, here again another number. Though the same numbers are there, they are different. Here 120, 11200 and 112000. It's not a repeating recurring decimal form, so it is not a rational number. So you can call it is a irrational number which cannot be expressed in the form of P by Q. Hope you all understood and this session was useful to you. See you again in the exercise 1.4. Thank you.